Hi everyone, we're trying a new way to do our flipped classroom, so we'll give it a whirl and see how it goes. So what I'd like you to do right now is start with your warm-up. We're starting with Unit 5, Day 1, Solving Systems by Graphing. Now by now everyone is really good at graphing, so you should have no trouble doing the warm-up. You'll notice that the first one is in standard form, so you should be thinking of our favorite thing to say, a teeny tiny table. And the second one is y equals mx plus b. So take a minute, turn off your video, do the problems, and then turn it back on. All right, now I will do it with you. So the first one is your teeny tiny table. First of all, I need to figure this thing out. So hopefully, there we go. Teeny tiny table, your x and your y. Put a 0 in for both. Now remember, if you put in 0 for x, you get to cover up the 2x and solve for y, then y equals 1. When you plug in 0 for y, you essentially cover up the y and put 2x, put in 0 for y, and then 2x equals 1, divide by 2, and x will equal 1/2. So let's go ahead and plot that. When x is 0, y is 1. So there's our first dot. My stylus is money. And then our second dot is 1/2 0. So this is just kind of a garbage graph here. So there we go. And then I'm going to connect them. Now my next one is y equals 3x minus 4. This is in slope-intercept form, where my slope is 3 over 1, and my y-intercept is negative 4. So we are going to put a dot at negative 4, and then we're going to do our slope up 3 over 1. And then I'm going to draw the line and go from there. Now it says, what point do they intersect at? Well, on mine, it looks like they intersect at 1, negative 1. I think my graph is garbage. So this is an estimate. Because I would need a better graph. But it looks like here it is 1, negative 1. So we would want to do a better job. I would want to give you really a better problem to do. So a system of linear equations is a set of equations that you work with all together. So a system of linear equations is a set of equations you work with at one time. So now a solution of a system is where they intersect. So it's an ordered pair. Now I will be looking for the exact ordered pair, so we will be looking for better graphs. Now, the next part of this is tell whether the ordered pair is a solution to the system. Now, how you tell if the ordered pair is a solution or not is you take the ordered pair itself and plug it into both equations and decide if it makes sense in both or not. So this first one, 5, 1, remember 1 is x, 5 is y. So you take both of those and plug it into both equations. So I will start with 1 for x. So it'll be the opposite of 1 plus 2 times 5. Does that equal 3? Well, 1 plus 10, does that equal 3? Does 11 equal 3? No. So I think right away we can tell that that is not a solution. Let's check the next one. I have an x and a y. Negative 5 for x. So it's the opposite of negative 5 plus 2 times negative 1. Does that equal 3? The opposite of negative 5 is 5 plus negative 2. Does that equal 3? Does 3 equal 3? Yes. Now I need to check it in the next solution, or the next equation. 2 times negative 5 plus negative 1, does that equal 4? Well, that's negative 10 plus negative 1. Does that equal negative 4? Does negative 11 equal negative 4? No. So it looked like it was going to be good, but in the end, it was not. Let's check our last one. The opposite of 1 plus 2 times 2. Does that equal 3? Does negative 1 plus 4 equal 3? Yes, 3 does equal 3. So we're off to a good start again. Now let's check the second equation. The opposite, 2 times 1 plus 2, does that equal 4? 2 plus 2, does that equal 4? Looks like this ordered pair works in both equations. So we have a solution. How do you tell whether an ordered pair is a solution? Well, you have to plug them in to both equations, and in order for it to be a solution to the system, it must be a solution to both equations. All right, next page. When graphing, if the lines intersect at a single point, then the coordinates of that point is the solution to your system. So let's go ahead and start graphing. Your first equation here is in slope-intercept form. I wish I could talk better here. So your slope is negative 1. Your y-intercept is 1. So let's start off by plotting our y-intercept. It is 1. Then let's do our slope. Down 1 over 1. 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 Okay, with the stylus, I don't really get a very nice line, but I'll do my best. Same thing, up 1 over 1. So that's my first equation. Now the slope is negative, the line is going down negative, so that looks good. My second equation is in slope-intercept form as well. My slope is 2 over 1. My y-intercept is negative 5. So I'd plot my point at negative 5. So I start here, and my slope is up 2 over 1. And on these, I just keep doing my slope until they intersect. And you can see right here, it's intersecting. And it intersected very nice. It intersected right here. So that is our solution. So our solution to this system is, I went over 2, down 1, so it's 2, 1. That is the solution to this system. It looks like that might be our notes, guys. We'll get used to this. Hopefully this will work well. We can find all